Hi, we are from Group 3 would like to present about absorption and its application.
And introduce to you our group members.
Next, I will introducing the introduction part. So above are the definitions of the term for chemical engineering. In simple words, it means that we're changing all raw materials into the functional products in a feasible way. So all these technique that we use not limited to one sectors only. We can go into multiple sectors and especially on the process itself. So we're using the maths, chemistry, and the physics to tackle the real-world products.
So, as a result, each unit's operation plays an important role for separating the impurities from raw materials or solvents that we use in producing the functional products from raw materials. So there were several examples of separating units involved, like distillation columns, absorption towers, humidification towers, and so on. As the separation process failed to do so, there were several scenarios will be happens. As the first one was the traffic jams, which are the separation unit fails to do so. The reactors must be shut down as we need to solve the separation unit. Otherwise, we are unable to get a high purity of products. While the other condition was running out ingredients, which at the downstream parts as subsequently packaging of fishing line are forced to stop due to lack of the feed. While some company may bear the financial losses due to the idle operation.
Absorption is a process where one substance is taken up by another, usually when a gas or liquid comes into contact with a solid or liquid and gets incorporated into it. It's an important separation process in chemical engineering because it helps control, purify, and recover valuable components. For example, in gas purification, we use absorption to remove CO2 and hydrogen sulfide from natural gas. In nature, plants use absorption to take in carbon dioxide, water, and nutrients for photosynthesis. Another example is ammonia hydrolysis, where ammonia reacts with water to form ammonium hydroxide. These examples show why absorption is essential in both industry and natural processes.
Absorption is a process where a gas gets soaked up by a liquid. Think of it like how a sponge absorbs water, except here a liquid absorbs certain parts of a gas. Sometimes the gas reacts with the liquid and it is called as chemical absorption. Meanwhile, for the physical absorption, it is just mixes in without reacting. So this usually happens inside a tall column or tower. Inside the column, the gas and liquid meet each other and the liquid absorbs the unwanted parts of the gas. So this helps clean the gas or separate the parts that we want. In the absorption process flow, a countercurrent operation is used. This means that the gas stream, which contains the solute we want to remove, travels upward while the liquid solvent flows downward. So as they meet inside the column, the solute dissolves into the liquid, creating a richer liquid stream and a cleaner gas outlet at the top. This mass transfer happens because of a concentration difference, which acts as a driving force. The diagram shows a packed column system connected to gas cylinders and a solvent tank, illustrating how gas enters at the bottom, interacts in the packing material, and lastly exits as a treated stream at the top. Packed tower uses packing materials to increase the surface area for contact between gas and liquid. In this equipment, liquid is evenly distributed through a liquid distributor and it flows downward over the packing. Meanwhile, gas enters from the bottom and is evenly distributed upward. The large surface area from the packing enhances mass transfer, making packed towers efficient for many absorption processes. And for the tray tower, which is a plate column, in a tray tower, gas and liquid interact on trays arranged in stages. As vapor rises through the column, it passes through holes and valves in each tray, while the liquid flows downward from tray to tray. When both phases meet, heat and mass transfer occur, allowing the solute to be absorbed effectively. Tray towers are commonly used when clear stage-by-stage control is needed for separation process.
Absorption is used in daily life for things like carbonated drinks, supporting aquatic life, helping us breathe, producing acids, and making ammonia cleaners. In industries, it is important for gas scrubbing, removing pollutants from flue gas, carbon capture, making nitric acid, and treating wastewater. Absorption has several advantages. First, it is highly efficient. It can remove more than 90% of target gases, especially when the gas dissolves well in the solvents. Second, the operation is simple because the equipment like pack or tray columns is easy to install and run. And lastly, the solvent can be regenerated and reused, which lowers operating costs and reduce waste. These benefits make absorption a very practical and economical separation method in many industries. Absorption also has limitations. First is corrosion and fouling. Some solvents or absorbed gases can corrode equipment, leading to damage and high maintenance costs. Second is mass transfer limitation. If the gas has low solubility, it transfers into the liquid slowly, reducing its efficiency. And lastly, there are operational issues such as flooding when liquid accumulates, foaming which lowers column performance, and liquid entrainment where gas carries liquid droplets off the column. This problem can affect overall system reliability and efficiency. In conclusion, absorption works like a liquid sponge that washes gases, selectively grabs impurities, and helps prevent air pollution from entering the atmosphere. Thank you so much for listening to our video.